Welcome to today's masterclass. The topic for today is arch wires. Now, what exactly are arch wires? Now, arch wires, these are base wires which are actually used to engage into our brackets, and the arch wire is what applies force. Brackets acts like a handle, and this force transmitted, the force from the wire is transmitted onto the teeth to bring about orthodontic tooth movement. So these are used to provide a proper arch form, and also can be used to provide a stable base. Like for example, if you have an impacted canine, so in base wire, the base arch wire which will be in the other teeth will be a strong wire, and then we can use a thinner wire to bring the impacted canine down. So this acts like a stable base. And any other auxiliaries can be attached to generate more force. Okay, so if you want to create an additional force apart from the force which the wire applies, so again we can attach all those different auxiliaries, means additional attachments can be added to this particular base wire. So when you consider arch wire, what should it basically have? First is large springback. Springback means if you deflect, okay, this is a wire, if you deflect this wire to one particular direction, it should come back to this original shape. That is, you take a wire, you bend the wire, when you bend the wire and when you leave it, it should come back to its original shape. Okay, so that is springback. How much a wire can be bent without causing any permanent deformation. Low stiffness. Now, stiffness is basically modulus of elasticity. Stiffness, we know, if something is stiff, it will be more resistance for us to bend. High formability means if we want to make a loop, or if you that is helix, or if you want to make a loop, the wire, we should be able to make a wire into a loop or a helix. High stored energy. Low surface friction. Low surface friction is very important because, see, we don't want any kind of friction between your bracket. Okay, you have your bracket here and we have your wire here. So we don't want any kind of friction between the brackets and the wire, because higher the friction, more will be the slower the tooth movement. Biocompatibility and environmental stability. It's very, very important, because you don't want the arch wire to create some kind of negative effect in your oral cavity. You don't want it to create some allergies in the oral cavity. You don't want the wire to release metal, or it should not cause toxicity. And environmentally also, if you buy a wire and keep it for a couple of months or couple of years, it should not change its property. Okay, it should not release any metals, or it should not release any gas. So it should be environmentally stable. It should not undergo corrosion. Okay, and then capability to welded and soldered. So as I mentioned earlier, there are various auxiliaries. So these auxiliaries are attached to the main arch wire with the help of either welding or soldering. The difference between welding and soldering is, if you take two metals and attach them with a third metal, it is called soldering. If you take two metals and attach them just by heating at this particular junction, it is known as welding. So welding is, you take two metals and attach them with just by producing some amount of heat, it's called welding. Two metals, if you require a third metal to attach them, it becomes soldered. So your wire should be easy to be welded and soldered, because then you can attach auxiliaries to carry out any additional kind of forces. So how do you classify arch wires? Now, most common is based on the materials which we use. So it could be a gold wire, stainless steel, chrome-cobalt wire, nickel titanium wire, multi-stranded arch wire, beta titanium, composite or coated wires, Optiflex wires. These two are aesthetic wires. Okay, aesthetic wires means they are good in appearance. Okay, they are more aesthetic. They do not give off their metal color, and they are more like how we use ceramic brackets. These will be aesthetic wires. Now, based on cross section, either the wire can be round. Cross section is, you take a wire, you cut it, and then you see what is the dimension or shape of the wire. It can be round, it could be square, or it could be rectangle. Based on the diameter, rounds can be 0110, 0112, 0114. That is, this diameter could be 0.10. So we say 0110, okay, 012 or 014. Square could be 016, 016 by 16 or 17 by 17. Rectangle rectangle could be, you have 17 by 25, 17 by we have like different, like you have 16 by 22, 17 by 25, 19 by 25. Okay, so you have different dimensions of the wires as well. Now first let's look at gold wire. It was used in the earlier days, so around 1930s. It was very inert, means it does not react with any other substance. It is biocompatible, environmentally very stable. The American Association of Dentistry has divided the gold alloys into two types, type 1, type 2. Type 1 has high amount of gold content, type 2 has less amount of gold content in it. Now, what are the basic advantages? It's extremely formable, low modulus of elasticity. Low modulus means it is low stiff, less stiff, it is very low in stiffness, and it is extremely formable, means you can bend it into whatever kind of helix or loops you want. Environmentally stable, it is biocompatible, it has good joinability, means it has good weldability and soldering potential. But disadvantage, it has very low yield strength, it has low springback, and it's very high cost. The next is stainless steel wire. Gold wires are not basically used right now. Stainless steel wires, what is the basic composition? You need to know this because it's a very common need question as well as Viva question. So it has 71% of iron, 18% of chromium, 8% of nickel, and carbon is less than 0.2%. Now, this 18.8, okay, so asked in orthodontics, 18 stainless steel is 18.8. This is again a neat question. They would say what is 18 and what is 8. So chromium is 18 and 8 is nickel. This is the most common basic orthodontic wires, and after its introduction, this is basically kind of dominated orthodontics. So its basic, its stiffness and resiliency were of great importance, and that's why it started becoming very famous. So what are the basic advantage? It's very high stiffness. So if you want to take support, if you want, if there's any kind of condition where you want the stable arch wire, this is arch wire of choice. It has very high yield strength, good stability, and it's biocompatible. What is the major disadvantage? High modulus of elasticity. That means it's very, again, it could be used as an advantage also, it can be as a disadvantage also. Frequent activation is required. Soldering is demanding because it's not very easy to solder into this, solder any auxiliary into the stainless steel wire. And when you heat this wire to up to like 400 to 900 degrees, that is usually when you can tend to solder. So when you want to solder a hook, for example, for retraction hook, you want to solder it. We usually solder it. So when we solder it here, that is that at that particular point, the temperature will rise very high. So in that condition, what happens? It tends to release nickel and chromium. Okay, and then when nickel and chromium tends, usually when chromium is released, at that particular point, it becomes, the resistance towards corrosion tends to reduce at that particular area. So this is a major disadvantage in case of stainless steel wires. The next is chrome-cobalt wire. Viva question, what is it also known as? It's called as alloy. It's also a neat question. Okay. So this is very similar to stainless steel, but it can be supplied in a very soft and a formable state. Okay. So initially, if you see, this wire will be very soft. It's very similar to stainless steel, but you know stainless steel is very stiff. Chrome-cobalt or alloy wire, when we get it from the market or the manufacturer, it will be very soft. So we can change it into whatever shape we want, and once we change it, we'll then heat it. Once we heat it, that new position will become very hard in that particular position. So we can modify at whatever dimension we want or whatever design we want. Okay, let it be 2 double loops. You can modify it this shape and then heat the wire. Once you heat the wire, it will become as hard as that of your stainless steel wire. When you consider alloy wire, the manufacturers give it in 4 different colors. Okay, it's color coded. So if it's a blue color, it means it's very soft and easy to bend. Yellow means it's very ductile. Green means it's semi-resilient. Red means resilient. Again, this is a neat question. Okay, types, different types. So what are the basic advantage? Excellent tarnish and corrosion resistance, greater resistance to fatigue and distortion as compared to stainless steel, and good formability. Once you form it, you can then heat it. Disadvantage, it will only gain its strength when you heat it. And again, similarly, soldering, that is connecting another auxiliary with the help of third metal, is demanding. The next is nitinol wires. Nitinol wires are very, very important wires. It's this is actually a short form for Nickel Titanium Naval Ordnance Laboratory, because it was in this laboratory it was initially first found. This has an excellent springback property, and it has what we call a shape memory property. That is, if you take a nitinol wire, niti wire, and you modify it into different shape, okay, and then if you just leave it, it will come back to its original shape. That is, it has excellent springback property. Now, nitinol is of two types. You have thermal nitinol and elastic nitinol. Now, first let's look at thermal nitinol. So initially it is basically consists of equal nickel and equal titanium. When you consider niti basically exists in different forms. When you look at it at molecular level, there are different types. Okay, so you have martensitic phase, and then you have austenitic phase. Okay, these are two different molecular form of your niti. So thermal niti has equal amount of nickel and titanium. It has a good shape memory in martensitic form. So we can change it to whichever shape we want in martensitic form, and then you have, whenever you apply some kind of heat, it gets converted to austenitic form. Wires with austenitic, so at the end result would be the wire in austenitic finish form. So when you consider elastic niti, the elastic niti, it is actually used in martensitic form. When you consider thermal niti, from martensitic form it gets converted to austenitic form, and we use the wire in austenitic form. Elastic niti, we use it in martensitic phase. Okay, it maintains very high elasticity and good flexibility, and it also exhibits desired property of light continuous forces. Okay, this is seen in both thermal as well as elastic niti. So the whole advantage of niti over other wire is light and continuous force. That is, if you deflect the wire like this, the rate at which it comes back to its original shape will be very slow. Okay, this is actually what we want. If this deflection, if it comes back to its original shape very fast, what happens is it applies a very high force on the teeth. Okay, so if this is a canine, it is applying a very high force on the teeth to immediately bring it down. So then what is the main disadvantage is it is not a physiological force. But on the other hand, when you consider niti, the rate at which the wire deflects is very slow. That means it's a very physiological force. That means it applies low continuous force, and this is an ideal kind of force for orthodontics. A low continuous force is what we should aim. So advantage: excellent shape memory, high springback, a good stored energy, high elasticity. Major disadvantage: it has high friction as compared to stainless steel. That is mainly because when you consider our brackets are basically stainless steel wire, but a wire is niti. So when you keep two different wires or two different wires or two different metals, when they rub against each other, the friction will be very high. But in the same way, if the wire is also stainless steel, friction will be less. And another major disadvantage is because of the presence of titanium, we cannot weld or solder. Soldering and welding is not possible. So we will have to shift to a stainless steel wire to bring about welding and soldering. So in case of wires, we saw basic arch wires, we saw different kind of classification, we saw gold wires, okay, we saw the advantage, disadvantage, we saw stainless steel wires, advantage, disadvantage, we saw alloy wires, which is nothing but chromium-cobalt wires, and then niti wires. How we basically use this: initially we use niti wire to bring about various alignment of the teeth. Once we align the teeth, once all the teeth is in the correct position, and then when you want to close your space, that is, if you have any retraction space, extraction space, and you want to close it, then you would shift to stainless steel wire. And during retraction, if you want to carry out any auxiliary movements, any additional movements, if you want to make any kind of springs, we can always use alloy wire. So with this, we come to the end of today's lecture. Hope you really enjoyed it. Thank you so much.